Hello guys, welcome to this tutorial where we are going to talk or discuss about recursion, okay, in programming. Okay, so what is recursion? How to use it? Why? Okay, that's so important to learn. Okay, as far as programming is concerned. Later on, we're going to talk about the algorithm and complexity. We are going to talk about the time complexity and space complexity. You are going to see the use of this, okay, as compared to the iterative method, right? So, some computer programming languages allow a module or a function to call itself, okay? That's this technique is known as recursion, right? Of calling itself a function, okay, to call itself back is known as a recursion. So in recursion, a function A either call itself directly or call a function B, then it then calls the original function A. So the function A is called a recursive function, right? So that's the concept of the recursion that is called itself back, okay? So of course, don't worry too much. We're going to take one example and then we're going to see how it actually works, okay? Some properties, okay? Recursion actually has some properties, okay? So a recursion or a recursive function can go infinite like a loop, okay? So it can go infinite like a loop. So to avoid infinite running over recursive function, there are two properties that a recursive function must have, okay? The first property is what we call the basic criteria, okay, or the base criteria, right? That's the base criteria. That's the first property. This means there must be at least one base criteria or condition such that when this condition is met, the function stops calling itself recursively. Let me take it back, please. This base criteria, that means there must be at least one base criteria, okay, or condition such that when this condition is met, the function stops calling itself recursively, right? That's the base criteria. Now, the second property is the progressive approach, okay? Progressive approach, right? So that's the second properties, okay, of the recursion or recursive function. This progressive approach, okay, the recursive calls should progress in such a way that each time a recursion call is made, it comes closer to the basic criteria. Very important, please, it's very important, okay, to understand the recursion. This progressive approach, please, means that the recursive calls should progress in such a way that each time a recursive call is made, it comes closer to the basic criteria. Okay, we say that the basic criteria is what? Is a condition such that when this condition is met, the function should stop calling itself, okay, recursively. I hope you actually understand the concept. How is that actually implement? Okay, what's the philosophy behind? So many programming languages implement recursion by means of stacks, okay? So they use stacks, okay, which is a data structure. We are going to see also. So generally, whenever a function calls another function, okay, on a function we can call caller calls another function, the callee, or itself as a callee, the caller function transfer execution control to the callee. Okay, this transfer process may also involve some data to be placed, okay, from the caller to the callee. Okay, so maybe the vocabulary is too high, but don't worry too much. As we're going to take an example, you're going to understand, okay, that which is very straightforward. So this implies the caller function has to suspend its execution temporarily and resume later when the execution control returns from the callee function. Okay, now let's actually go ahead and implement a factorial using the recursive approach. Okay, so let us write our, of course we are going to declare a function. Okay, let me just, I can just include the library here. Okay, the std, alright, simple like this, and then I can just declare my function, the factorial, with a long called factorial, like this, alright, factorial, then int, n, which takes of course the number n in parameter, and then it's going to return the factorial. First I'm going to say if n is equals to 0, or n is equals to 1, then let me just write, I'm going to explain in a minute, then just return 1. You know that the factorial of 0 and 1 is actually 1. Else what are you going to do? Else you just return, right? Just return what? Return n times factorial, the function called itself, minus 1, and that should be okay. So we have a function which is going to return a long, the name is a factorial, which takes an n in parameter, and then check if this n is equal to either 0 or 1, then it's going to return 1. That's the factorial of 0 or 1. Else what are you going to do? This one, please, this one is the base criteria. That's the base criteria. From the previous explanation, this one is our base criteria. So we are going, this function factorial is going to stop calling itself when this criteria is met. So now it's met. So this one is the base criteria. Now else, if it's not the case, then just do what? Call the function itself back. But as you can see, we are actually we multiply times n, and we decrement the value that we are actually passing to the function. We are decrementing till n is going to that one is the progressive approach to tens to the base criteria. As we are going to reduce the value of n, we are going to actually go closer to the base criteria so that the function is going to stop calling itself. That's why we're actually decrementing one by one. And of course that's the logic behind the basic criteria. So how you get you got the concept of the recursion. Alright, you can just go in your main function and test this if you want. So you can just see factorial. Just print percentage d. Even though this is going to return a long, let me just put percentage d, and then factorial of 5. So and then you can just return the 0. Like this. So let's go ahead and compile this program and see what it actually shows. So let me just like this. This one is actually the recursion, right? Recursion like this, and then percentage d. Of course this one is actually a long, will not work. Let's just put the ld, right? The placeholder. So let's go ahead and do this, right? Normally it should be 120. That's the factorial of 5, right? So when this, how this calls actually what happened exactly is that when we pass 5, it checks 5 is not equal to 0, neither 0 nor 1. Okay, then it's going to do what? Return. Okay, put this into a stack, this 5. Okay, and then call this function back, right? So it's going to put 5 in the stack and then call the function back with 4. Now as we are going, you see we're actually going to the, okay, closer to the base criteria, right, where the function is going to stop calling itself. So it's store this into a stack. Okay, as we said, they use the stack, some programming language using the stack approach to, okay, do that. So it's going to store 5 and then call itself back, which is going to do what? 4. It's going to store 4 and then times, okay, each times 3 and then 2, 1 and then stop. Okay, so that's all about the recursion. Okay, I hope you got the concept. It's very important. Thank you guys for watching and see you in the next tutorial then. Bye.